Hello everyone. In this video, you will learn how to identify oxide, peroxide, and superoxide ions in ionic compounds. First, we need to know what is an oxide ion, right? So an oxide ion is when we have an oxygen with a -2 charge. A peroxide ion is when we have O2 with a -2 charge. And a superoxide ion is when we have O2 with a -1 charge. Okay, so I'm going to explain this with few examples. Okay, so these are the examples that we are going to solve. Okay. Okay, so the first one that I would like to solve is this. Okay, and I'm going to show you how to identify what type of ion is this. Is this oxygen over here. Okay, so notice that what we have here is a manganese, right? Manganese is right here, right? So this is it is a transition metal. Okay, so we know that transition metals, the charges are not that predictable, right? They change. They can be, for example, in this case, they can be +2, they can be +4, and they can be +3, +7. Okay, so it can give you some charges that are not given in this table. Okay, so they are not predictable. However, we know that these elements here in column 1, 2 are very predictable. And also all of these elements here in this area, right? So they are very predictable. Okay, so they are very predictable. Okay, so this is something that we need to know. Okay, and I show you in a minute why. Okay, so for example, how we can analyze this. Okay, so we can say, okay, so we have manganese, okay, and we have oxygen. We have one oxygen. Okay, so we know that oxygen always is going to be -2. Okay? Always is going to have a charge of -2, right? This is very predictable. Okay, so for manganese, well, we don't know exactly. It's going to be what? +2, it's going to be +4, maybe +7 or +3. Well, that's something that we can find out. Okay, so how we can do this? Okay, so we have O2 or oxygen with a -2 charge, right? So I'm going to write this way. So we have a -2 charge. So that means that for us to get this formula, this manganese has to be 2+, right? Makes sense, right? Because if we have manganese here and we cross the charges, so this will be 2+, so that will be 2 here, 2 here. But we know that this, we cannot leave it like that, right? We need to simplify this, so we have to divide by this number. So then we're going to get what? We're going to get the same formula that is given here. Okay. Okay, so what that means? So that means that this oxygen, okay, so that means that this oxygen here is actually an oxide ion. If we want to write the name for this compound, so that would be so because manganese is a transition metal, it can have different charges, so we need to specify which one, right? Oxide. Okay. Okay, so this is our first example. Okay, so we are going to do pretty much a similar analysis with the other ones, okay, and see what we get. Okay, so this is our second example. Okay, so now we have manganese, but now in this case we have O2. So we want to know if this O2 an oxide ions, or is there, or it is a peroxide ion, or maybe a superoxide ion. So let's see. Okay, so let's do this. So something that we can do, we say we do the same thing. Okay. So something that we can do here. So we have oxygen over here. Okay. So let's assume for a moment that here what we have are oxygen and oxide. Okay, so that would be -2 here, -2 here. Okay. And I want to start with oxide because we know that oxygen is a very predictable value, right? It's always -2. Okay. Okay. So if we do this, so in reality, what we have is -4, right? Because we have two oxygen with -2 each, so that is -4. Okay. Okay. So in order for this have, if this is -4, that means that manganese has to be +4. Why it has to be? Well, because we know that this compound here have no charge. So that means that my charges have to cancel out, right? So they have to give me 0 at the end, okay? So what this means is that these oxygen over here are actually oxide ions. Okay. Okay, so something that we can do just to check, right? Something that you can do, you can say, okay, so what about if we have this? Okay, have taken into consideration the charges that we have over here. So then if we cross the charges, right? So that means that here we get here, and here we have here. Okay. And well, we do the same thing, right? We know that we cannot represent that in this way, right? Because we need always to simplify to give the smallest ratio as possible. So we're going to end up with the same formula, right? That is given, okay? So this is my what? So that means that these are oxide ions, okay? All right. So now if we want to name, right? If we want to write the name for this compound, so that would be there will be 4, right? Because manganese here have to be 4. Oxide, right? Manganese 4 oxide, because we just find out that this O2 here are 2 oxide ions, okay? Okay, so let's go to our next example. and we can perform the same analysis. Okay, so here let's say that we have the SR is right here. Okay, so, and that means that strontium always is going to be what? It's always going to be +2. Okay, it's always going to be +2. That is not going to change. Okay, so something that we can do here a little bit different than here, because this is manganese, that is a transition metal. So we can start taking into consideration the metal, because we know that always is going to be +2. Okay, and here we are going to have what? My oxygen to here. Okay, so if here we have +2, so these O2 have to be what? They have to be -2, right? Make sense? They have to be -2. And if this is -2, so that means that this is a peroxide. Okay? Because with these chargers, with this charger, we are going to get what? The same formula that is given. Okay? Right? We cannot use what oxide, because the oxide, right? The oxide are going to give me what? If we have two, they are going to give me a -4 charge, right? If we have here -4, so that is not going to make sense, right? Because they're not cancel out. It's only going to cancel out when we have a -2 charge, and that is a peroxide. Okay, so that means that this oxygen here, this O2 here, is a peroxide ion. Okay, okay. You see, so what I did here is, because this metal, right, we know that it's very predictable. The charge for this metal are very predictable. So I took this one of my reference, and then I identify which one is going to, which species is going to cancel out my charge, and that is the -2, which is a peroxide ion. So the name for this compound is strontium peroxide. Okay, excellent. So let's see two more examples and do the same analysis. Okay, so let's talk about this. So here, so what we have is rubidium. Okay, so if we look for rubidium, rubidium is in my first column on the periodic table. So we know that it's going to be +1. Okay, so let's do this. But we have always is going to be +1, but something we have here. So we have two of them, right? So we have two. So we have, I'm going to represent that in this way. I think that is easy to visualize. So we have two, right? So we have two. So that means that actually we have 2 plugs, right? So we have one for each rubidium. Okay. So we know that the charges for rubidium is very predictable. So if we want to know, if we need another species with a -2 charge, so they can cancel out, right? That's what we need. And the charge for that is what? Peroxide. right? We have O2, okay, because we know that the O2 is have a charge of -2, okay? And if we use these charges to get the chemical formula, so we are going to end up with this, the same formula that is given, okay? So that means that these here are actually peroxide ion. Okay. Okay, so the name for this compound is rubidium peroxide. Okay, so let's see our last example. Okay, so let's see what we have here, right? So here we have cesium and O2. We want to know again if this O2 is an oxide, is a peroxide, or is a superoxide. Okay, so something that we can notice here is that cesium is in column 1. So that means that cesium always is going to be +1. So we say, okay, cesium is +1. Okay, so that means that my charge, we have only 1. So that means that here we have +1. So which species can be -1 to give me, to cancel out the charges? Well, the superoxide. Okay. So we know that if we have O2 with a charge of -1, that is a superoxide, and that is exactly what we need here. So these two guys cancel out, the charges cancel out, right? So now these O2 here are superoxide ions. Superoxide ions. Okay. Okay. So remember that what I'm doing here is I took the metal or the species that have a predictable ion, and I took that one as my reference, right? And then I identify, so which charge do we need? Which of these charge? -2, depending on what we have, or -1, and then make sure that they cancel out, and we can identify which type of ion do we have. Okay, so the name for this compound is cesium superoxide.